In section 1.4, we're going to be working with um, evaluating the trigonometric functions of any angle. So we've worked with common angles, and so multiples of 30, multiples of 45. And we're going to talk about reference angles and evaluating the trig functions of real numbers. So one of the things that came about when we talked about the unit circle is that I could find sine would be the y coordinate and cosine would be the x coordinate and tangent would be y divided by x. And the reason that sine is equal to the y coordinates because you have a radius of 1. And when you divide y by 1, you're going to get just y. But this can work with any size radius, but what we'll have to do is find the distance for the radius. So what we'll have to find is the radius of our particular circle. So when we worked with the unit circle, it had a radius of 1. And in this case, we're going to be working with radii that are not 1. So when we take a look at how this happens, I get a problem like this one, where it says, let negative 2, 3 be a point on the terminal side of theta. So I'm going to go ahead and bring out a graph for this one, just because I think it's easier to visualize if we actually use these points. So we're going to go to negative 2, 1, 2, 3. So here's negative 2, 3. There's that point. And so we're talking about an angle in standard position that goes like this. So the angle we're talking about is this angle here. All right, and now that I know that my y coordinate is 3, my x coordinate is 2, and I need to find what the radius is because I can make this right triangle here where I've got negative 2 there and I've got 3 there, and I need the hypotenuse. So I know I'll have negative 2 squared plus 3 squared is going to be equal to the radius squared. So 4 plus 9 equals the radius squared. So the radius will be equal to the square root of 13. Okay, so if that is root 13, I'm going to write that here. That means that sine is going to be my y coordinate, 3, over root 13. And when I rationalize the denominator, I'll get 3 root 13 over 13. Now cosecant would be the inverse of this here. So cosecant would just be root 13 over 3. Okay, so if in the situation we have to rationalize the denominator for sine, I won't really have to do that for cosecant, which is convenient. When we think about cosine, will be the x-coordinate, negative 2 over root 13, which, by the way, means that secant is negative root 13 over 2. So there's secant. And when I rationalize the denominator here, I'll get negative 2 root 13 over 13. And that's my cosine. So my tangent is going to be y over x. Well, y over x is going to be 3 over negative 2, and that's negative 3 halves. And then cotangent will be the inverse of that. It'll still be negative, but it'll be negative 2/3. Okay, so the steps for me is I have to find the radius, and then I have to use these rules here, that sine is y over r, that cosine is x over r, and tangent is y over x, and then we go right ahead and we figure this out. Now, in this particular case, we're looking at a slightly different situation, but I've got a lot of information here that I can use. So again, I'm going to pull out a graph really quick. I know that sine was 4 over 5. Okay, that means that y is equal to 4 and the radius is equal to 5. And I'm going to need to find x. Well, x squared will be equal to my radius squared, which would be 25, minus y squared, which would be 16. So that would be 9, so x is equal to 3. Okay, so if x is 3 and y is 4, but there's this other piece of information. Tangent is less than 0. Oh, so tangent must be negative. That makes this a little more complicated because I want to think about, right, in this first quadrant, y is positive, so sine is positive. X is positive, so cosine is positive. And sine divided by cosine, which would be tangent, is going to be positive. A positive number divided by a positive number will be positive. Now over here, we know that sine is positive. I know that cosine is negative, and consequently tangent is negative. So now, this is a possible quadrant for my angle to be in. Over here, I know sine is negative, cosine is negative, and tangent is positive. So it couldn't be this quadrant, and it couldn't be this quadrant, because my tangent has to be negative. And you'll notice my sine was positive. Over here, my sine is negative, and my cosine is positive, and my tangent is negative. So the tangent part works, but the cosine part doesn't. So it must be over here. So this x is actually negative 3. 1, 2, 3, 1, 2, 3, 4. This is my angle. And I want you to show how a process of elimination, a logical examination and possible and elimination of unacceptable situations allows you to find the correct quadrant for your problem. So I know I have negative 3 and I have 4. For my sides, I know that this is 5. And if I want to find my trig functions, I know that sine, they already told me, is 4/5, which means that cosecant is 5/4. I know that cosine is negative 3/5, and so secant is negative 5/3. And I know that tangent is going to be 4 divided by negative 3, so that's negative 4/3, and cotangent will be negative 3/4. Okay, so process of elimination allows me to place it in the right place. Remember, it's hard to tell when I take the square root of 9, it could be positive 3 or negative 3, and then I have to go back to this other information to figure it out. Okay, if we go through and start talking about the trig functions of quadrant angles, and those are the angles that define the quadrants, so 0, 90 degrees, 180 degrees, 270 degrees. Or in radians, that'd be 0, pi over 2, pi, 3 pi over 2. If we want to look at these, when we talk about pi over 2, we want to do sine and cotangent. All right, that's interesting. So the sine, here we're back into a unit circle. The sine would be the y-coordinate. Sine is equal to 1. And cotangent, tangent would be y over x. That would be undefined. But cotangent is equal to 0 because it's 0 over 1. Right? Cotangent would be x over y because tangent is y over x. Now if we talk about, oh, we wanted to do 3 pi over 2. I'm sorry. I did the wrong one. But if we do 3 pi over 2, I was going to do all 4 of them. The sine value is negative 1. Sorry, sine is negative 1, and cotangent is 0. Okay, so again, we're working, in this case, we were back to working with the unit circle. Now, what happens with the other functions, right? If I wanted to know cosine of pi over 2, cosine would be 0. But if I wanted to know tangent, it would be undefined because it would be 1 over 0. So in these two angles, our tangent is undefined. In these two angles, our cotangent would be undefined based on putting 0 in the denominator of a fraction. Okay, we want to talk about a reference angle. A reference angle is the acute angle theta formed by the terminal side of theta and the horizontal axis, meaning the x-axis. So in this case, you look at this problem, this is the reference angle. And in quadrant 1, if I want to find the reference angle, I'm going to do pi minus the angle if it's in radians, or 180 degrees minus the angle if I'm in degrees. If we go on to quadrant 3, this is my angle, so it's going to be pi plus the angle. Oh, in this case I said the angle minus pi. Okay. It could be angle minus pi or the angle minus 180. Often we ignore negative, right? So this is not going to result in a negative item. Right? So this is accurate. Let me go back. So for this angle, it would be the angle minus pi or the angle minus 180, depending on whether you're in radians or degrees. And we get into quadrant 4, it's going to be found, it's this angle here, so it's 2 pi, which is all the way around the circle minus the angle, or 360 degrees minus the circle. And why didn't they talk about quadrant 1? Well, in quadrant 1, the measurement of the angle is the reference angle. Okay, because those angles are all acute angles, and their measurement is the difference between, is the measurement from the horizontal axis to the angle. Okay, reference angles are important because the reference angle will have the same sine, cosine, tangent function as this angle. And it's important also when you're working with using your calculator to identify angles based on knowing the sine function or the cosine function or the tangent function. It's going to give you a reference angle, and then you have to locate it into the correct quadrant. So right now we just want to figure out reference angles. So we think about 213 degrees. That's over here. Right, so it's going to be 213 degrees minus 180 degrees. Right, that's how I would find this measurement here. This measurement is 213. This is the measurement that we want. So 213 minus 180 will be 33 degrees. That's our reference angle. And when we think about 14 pi over 9, 14 pi over 9, that's 4 pi over 9 short of 2 pi, right? So it's going to be someplace over here, 14 pi over 9. So we're going to do the full circle, which would be 2 pi or 18 pi over 9 minus 14 pi over 9. That's going to be 4 pi over 9. That's our reference angle, 4 pi over 9. Okay, so if we want to go ahead and start doing trig functions again of any angle, they're going to have me determine the function's value based on the associated reference angle theta. Here's the reference angle. And depending on what quadrant it lies in, put the appropriate signs on the function value. So what will happen is we're going to get, if I get values for this, I'm going to be, it's like it's an angle in quadrant 1 where everything's positive, but I have to put positive or negative correctly depending on what quadrant I'm in. So if we take a look and do this, we want to find sine of 7 pi over 4. Well, 7 pi over 4, that's in quadrant 4. So my reference angle, if I want to find the reference angle, I'm going to do 8 pi over 4 minus 7 pi over 4. That's pi over 4. Okay, and I know that the sine of this is the same as 45 degrees. It's root 2 over 2. But when you think about quadrant 4, that's down here, quadrant 4, my y-coordinate would be negative. So this would be negative root 2 over 2. Okay, if you want to talk about cosine of negative 120 degrees, negative 120 degrees is right over here. right? My reference angle will be 60 degrees right there because that's how much further I'd have to go to get to 180. 60 degrees, the cosine of 60 degrees would be 1/2. But you'll see over here, that would be if I was up here. The x values on this side are negative, so it would be negative 1/2. And if we look at 11 pi over 6, that's 12 pi over 6 minus 11 pi over 6. This is also in quadrant 4. All right, that's going to be pi over 6. Well, the tangent of pi over 6, well, that's complicated. That's going to be my y-coordinate, which would be 1/2, divided my x-coordinate, which would be radical 3 over 2. That's got to be 1/2 times 2 over radical 3. I invert and multiply. The 2's cancel. I get 1 over radical 3, and then I rationalize the denominator, so that's radical 3. I'm sorry. That's going to be radical 3 over 3. Okay, now, that's in the fourth quadrant. Is tangent positive or negative? Well, my cosine would be positive and my sine would be negative, so my tangent will be negative. So this is negative radical 3 over 3. And that's going through using the reference angles, which were all common angles, right? Pi over 4, 60 degrees, 30 degrees, or pi over 6. And then I used what I know about the unit circle, which we've already studied, to find these values. And then I place them in the right quadrant and make them appropriately positive or negative, depending. Okay, let theta be an angle in quadrant 3. So theta is down here. There's theta. Such that sine of theta equals negative 4, right? 1, 2, 3, 4. Negative 4 over 5. So I know that this side is negative 4. I know that the radius is 5. That means that this side is negative 3, right? Because it's in quadrant 3. This is a 3, 4, 5 right triangle. Great. So I want to find cosine of theta. Cosine of theta would be negative 3 over 5. And tangent of theta would be, in this case, I would have y over x, so it would be negative 4 over negative 3, which is 4/3. Tangent theta. Okay, so really quickly I sketched it into place. It was easy to find the 3. You notice I didn't use the Pythagorean theorem because I know that if one side's 4 on a right triangle, if one side is 4 and the hypotenuse is 5, the other side has to be 3. It was in the third quadrant where both x and y are negative, so it had to be negative 3. And then we were able to evaluate. So just to summarize, we went through the definitions of the trig functions of any angle. We did examples evaluating those trig functions. We went through a reference angle and finding the reference angle and using the reference angle. And then we went ahead and evaluated the trig functions of real numbers.